Hello, this is the recording of the API summary for Group 5, who are compiling all the other group projects together to produce the final sort of output. So to start, we look at our API summary, which has all the info about what we will be doing in over the course of this project. So we had to make a couple assumptions since we don't know what the other teams, how they're going to be implementing things. So in sort of an object-oriented type mindset, we made the assumption that each of the other teams will have a file, will write a function that does a task and then loads the data to access the product of that task into a register. So that would make our job a lot easier, and to do that, for example, the I/O team, we are assuming, will have a function that accesses a file and then stores, which in our case is assumed to be a what's it called? A JPEG or something like that, or a PNG with pixel values at each of the locations. Since MNIST, it's 28 by 28. So it'll be a file with 786 or something pixel values, and that function will load each of those into a stack as used in the last few projects. And then once those are loaded into a stack, it will return the the base address of that stack, and then we will be able to access each pixel value every 4 bytes in that stack is the next pixel value. Then we assume that the classification team will, knowing that that is how the I/O team is going to be implementing their stuff, will be implementing a function that takes that stack, iterates through it while multiplying by weights and biases, and then will, after all of that, it takes the stack, and then after putting it through that vectorized, so this we're assuming is going to be based on the vectorized work as well, and so we won't necessarily have to worry about that. And then this classification will be stored as a char, not as an int, that is important, as a char in a register. Then, once it's a char, we'll just call another printf function and be able to print that classification. So on our end, assuming that this is how the other teams have implemented sort of their work, we believe that this is our part of the project is actually going to be pretty simple. But I mean, if this is an assumption, if maybe they don't and we have to do a little bit more Frankensteining, putting things together, then it might not be quite so easy. So essentially, our API, in terms of if you as a user would like to utilize this program, essentially all you have to do, as we've written this, is put the name of the file in a string at the top in the data section, and then run the file. And we will then take that, and then it'll go through a main loop that first stores that file name in a register, prints the file name, just so, for, as like I say in the dcheck, making sure it has the right file, calls the function that loads the pixels of that file into the stack, that's the I/O function, puts the base address of the stack into a parameter register, that's going to be A0 or A1 again, then calls the classification function, which we are again assuming uses this stack of 786 words, then loads that classification into a parameter register. Again, this is going to be a char, not an int. Then calls that printf function. This is so that we can just use one printf function and not a different print function like the ecall, like when we can use A1 or A0 equals 4 instead of A0 equals 4 and A0 equals 1. It's just one function that we have to call. And then finally, it just terminates the program and is done after that. Yeah, pretty interesting stuff. And then outside of that, all the functions are just going to be on the same page outside of the main loop. So you as the user will be able to just look at this main loop and it'll look like how it looked on assignment 3 with just a few printf functions, a couple well-named functions in the middle, and then you get your classification. And then, yeah, all you have to do is write the name of the file they would like to be classified into the top of the program. Check, is there a way to check to make sure? Yeah. Yep, alright, and that's all.